So I'm going to talk today about engineering and what I've learned in dealing with all you guys for about 8 years. And I'm going to set a background for that. So some of the statements that I make are going to be complete. Some are maybe going to be incomplete. Some of you might be like, wow, that's the deepest thing I've ever heard. And some of you might be like, all right, I'm just going to put that in the happy box. So if there's anything here which makes you think or raises questions, then I've achieved my goals. So I want to mention a couple of things. And this is some stuff that I say during the open house, and a few of you have maybe seen that when you come with your parents. So things like engineers don't solve problems, they address challenges. That's what I like to say. There is no extreme in engineering. And I really want to focus today on this. And I'm glad there's so many students today because I don't think in this field there is enough emphasis on your journey and what you can accomplish. So I'm going to throw some opinions on that today and see if I can get people's brains moving a bit. And the last thing is you are not alone, stealing from Doctor Who. So this is the first thing I want to show, and I hope you can see this globe. It actually took me about 10, actually more like 20 minutes to realize like which globe picture I wanted, because I wanted to represent everyone, and then I get all worried when like Greenland is monstrous and a Mercator projection and things like that. But I finally settled on this one because it shows all the nice geography of the world, and my mom's a geography teacher. So I want to show you these quotes that came from this gentleman, John Dewey, who's a philosopher and psychologist. And you don't have to read the whole thing, but there's different things like this. Like he's talking about the influence of technology on society and how quickly things are changing. You know, great inventions that have utilized the force of nature, rapid means of communication, habits of living are altered with startling abruptness and thoroughness. This all sounds familiar to you. I hope it does, because this is all we seem to talk about these days. But one thing I want to mention is that this is a quote from 1899. How many of you all knew that? I bet a couple of you did. All right, well, one of you did. That's good. But this is good. This is a surprise. People have been talking about this whole idea of technology and the whole idea of its intertwining with society for decades now, and this guy brought it up in 1899. Best part of my job is partly running Capstone Senior Design, and some of you have been through it, and some of you will be through it. And basically what we do is we throw students in the deep end, and in 6 months, they have to basically take an idea and they have to make a final working prototype. And they have to go through all the presentations and teamwork and ideation and everything to accomplish that, and they never, ever disappoint. None of the best parts of my job are, as Marilyn mentioned, I advise several clubs on campus, and I'm going to kind of put some lessons out there. What you're going to hear in my talk is what I've learned from students and stuff, and this is what I've learned from some of these folks. This is the SAE Mini Baja team, this is the SAE Potential E Formula team, and one of their mantras I've always noticed is always have a plan B. You don't always get your plans or your requests or hell, even time with me or other professors right away, so always make sure you have something else going on. Don't wait for people to sort of say, all right, that's okay to move forward with, or I'm going to give you this sort of adjustment on this. Have something else to do. Have something else in the back burner. And these other three we've got here, this is NEU Toys, a club that we founded. This is AIAA, a club a lot of you probably know about. And this is the Growing Kitchen program, which is students teaching students. And the thing I've learned about the leadership of this one is even if you're facing a challenge on one day, do your best to make somebody else's day better. At the best, you'll help somebody else, and at the worst, you'll forget about your own challenges for a while. And the folks who've started these clubs have really, really exemplified that over the years. So the title of my talk is what I've learned from 1,000 engineering students, because I think I've probably interacted with about 1,000 or with an order of magnitude, I guess. So there's the subtitle, Observations, Conversations, Frustrations, and Altercations. You guys get frustrated, you fight. I get every email whenever anybody's dissatisfied with their course and they want their money back or something like that. That email always comes to me. I want to say the observations I've made, and I don't make anything totally definite, but I also want to put my own opinions on those. And the first one is you want to participate. I can tell this from anyone who comes in. Anybody who wants to do really well in their classes, wants to do design, wants to do entrepreneurship, just wants to do well. Everyone wants to participate, and that's good. We can always work with that. And this is true. Mechanical engineers, if you've been to my open house, you've seen this, responsible for a lot of the world's progress. But engineers were also, we've had a hand in some of the challenges as well, too, and some of the failures. So, this shows a technical side, but there's a lot of stuff to clean up out there. There's a lot of opportunity to make this place better. And you're not just going to do it with technical prowess alone. These are the types of folks that we need to be engineers these days. You are ambitious. I've seen that. You need to be careful, fearless, cross-disciplinary in your thinking. You're learning that, and I see this all the time when I watch you guys. So I'm going to give a note on diversity as well, too. Okay. This is the thing. Engineers are very well equipped to speak across diverse groups. You have the more classical notions of diversity, which we have here. But one thing, and I think a few of you may be seeing this, is there's other types of diversity, education and background, sector responsibility. Like, how do you get two people from two different worlds or two different socioeconomic backgrounds to talk to each other or to agree? Focus and depth. Somebody might spend their life working on just one thing, and somebody might spend their life working on a bunch of different things spread all out. How do you get those people to talk? How do you get those people to work together? That's the type of thing that's really going to allow us to move forward and solve problems. And that'll be kind of a common theme of what I talk about here. I like to think that engineering gives us a common language, but we can't take any of this stuff for granted. Like, a lot of times what you'll do is you'll go to an engineering school or something and they'll say, oh yeah, engineers can talk across this. We can really address diversity. But none of this stuff just happens naturally. You need to actually focus on it and say, I am going to attempt to reach across the aisle here. It's not just something magical about engineering that does that. This is something about engineering recruitment, and I'm going to also talk about this today, and this is where people can agree and disagree. Not enough people are becoming engineers. As universities, we often think that. As the technical field, we often see that. We hear about the shortage of an engineer. And one way we try to do is we try and recruit folks to do that through things like STEM education, but we also use buzzwords. And I get you guys have probably heard a few buzzwords, and I have particular opinions on some of these buzzwords, which you may or may not share. And one is innovation. Who here has heard the word innovation? Who here has heard that they are supposed to be innovative? Who here knows what the hell innovation means? Okay, good. Okay, so neither do I. There's a lot of different ways. Now, it is true that if we look at innovation, part of it is invention. And that's a very, very small part of it. It's an important part, but it's a very small part of it. And I think sometimes when we talk about innovation, either in the curriculum or in the design or just as engineers, we think about, yeah, I have to invent something. Oh my God, that's my main thing. But we often forget that innovation is not just making something new or coming up with a new idea. It's actually reasonably successfully getting somebody to adopt it as well. And that's a lot more difficult in some cases than the invention itself. So it involves things like ideas, communication, motivation, teamwork, operations, all those types of things. I think management as well too. So this is something I want you to think about. Again, I'm just going to give you a peppering of ideas today. If you want to be innovative, where are you in terms of your ability or your desire to invent, but where are you in terms of your ability to just work with other people? And how can we use our time at Northeastern to learn a little bit more about that? You want to participate? Okay, let's talk about that. Let's talk about the word create. I gave a talk a couple of years ago at the Society of Asian Science Engineers. I gave a keynote talk there, and they wanted me to talk about create. How do I create? How do we create? That word just came up, and it started to bug me. So I said, okay, fine. So let me think about hearing the word create. So I hear create. And this is probably what you guys hear all the time. At least I see it all the time. It's like, it's your responsibility to change the world. Oh, how about we fix this car? No. That car has too many wheels. Make one with 5 wheels. Not too many, too few wheels. But either way, make something totally new. Otherwise, it's worthless. And we hear this quite a bit with words like disruptive and stuff. And there's all this pressure on you guys. 20 under 20. I mean, a few of you probably missed that. 30 under 30. A few of you have a shot for that. 7 billion under 7 billion. So there's all the question of, what have you done today? I've sort of had these conversations with people. I over-dramatize things a little bit, but it tends to make the point a little bit better. Okay, so this is one conversation. I got a virus off my friend's laptop. Okay, great. Did you do? Well, no, I just used Google and YouTube and it worked. You didn't create, that's wrong. You're an engineering student. You're supposed to do something a lot more shiny than that. Okay, but never mind the fact that your friend was okay and helpful with it. Okay. This is something we made. We didn't really invent it. There were shy dogs at the Animal Rescue League of Boston, and we tried to figure out a way to make a dog-proof shelter that dogs could hide behind. So we basically designed this, and somebody said, oh my God, did you patent that? Well, no. We just kicked over some Home Depot shelving, and the dog was pretty fine. It's like, well, you didn't create, Well, it doesn't matter, the dog, right? So these are all things, if you think about when people talk to you about these words, it's up to you to think about what they really mean. This is one of our best capstone projects. I don't want to say, okay, they're all our best capstone projects, but this is one of our best capstone projects. We've made an adapter to allow a congenital transradial amputee to operate a walk-behind tractor. Okay, wow, are you going to send them to a third world country, make 10,000 of them? Well, no, we're just going to focus on one person. And I actually know a couple of people in this room who've done this as well, too. I don't want to make something which is going to impact 10,000 people right away. I want to help this person or this person, a friend, a relative, somebody I saw on YouTube who seems to be having problems. I just want to do for one client. Oh my God, think of the potential impact. Well, no, we want to work on that. So in our rush to create, in our rush to invent or innovate or things like that, we often forget it's totally fine to help one person. But still, you have this type of pressure, but this is the type of thing when you hear this, think about it. Think about, what you actually want to do and how you can make your impact. And this is another one, say, hey, I adapted a controller for a radio-controlled car, so I can work on one hand, and usually the response is, that. So, you're wasting all this, what the hell, Not everyone creates, okay? This is a company that my dad worked with and eventually took over. It was a record manufacturing company. And I learned from him, he just went, because they said, hey, our records aren't being manufactured properly. Can you come by and help us? He didn't start the company. He just helped them improve their process and eventually took over the company. Very creative thinking companies like Tesla, like Apple, these ones that are really popular with co-op and things like that, doing some real innovative stuff, they're not just creating all the time. They're doing other stuff. They're doing clever things, but it's not just pulling something out of a vacuum, and that's the message I want to bring. Airplanes. One of the reasons why we can fly 15 hours around the world now is because we're making lighter aircraft, but we're also making much, much more efficient turbines, gas turbines, to fly these aircraft. And that is coming from incremental progress on these things, turbine blades. We are getting them to operate at higher and higher and higher temperatures, slowly from 1965 to 2015, but we are making progress. And you can see here, we've changed the operating temperature from about 900 degrees C to about 1700 degrees C. And if those of y'all are taking thermo, you should know that that improves the efficiency of these things dramatically. Use a lot less fuel, a lot less waste, things like that. So this is incremental progress. This is just making stuff better, but this isn't creating. These folks, ladies and gentlemen, from a couple of years ago who discovered gravity waves, they put things together, but they basically just did a bloody good job of making a very solid measurement device to measure these things. So there is a rush to create, and there's a pressure for that, but it's not all we have to do. So I kind of want to go through these other words that you guys can do as well too. Create, fix, improve, help, listen, consider. These are the types of things. These are all types of opportunities. I bet if you sit down and think about it, you could figure out opportunities for these as well too. And I'll give you some examples. I'll give you an example of finish and sustain, okay? Now this is an outright recruiting tool, okay? A couple of years ago, Max Choate came to me and said, I want a hovercraft. And I said, no. And he said, all right, what can you do? And I said, well, let's make you a radio-controlled hovercraft. And we came up with the idea of creating a radio-controlled hovercraft racing league at Northeastern University. We don't have one yet because reasons, but what we did do is we made a prototype in Capstone. There was no good radio-controlled hovercraft out there. So this team made of these 5 young gentlemen, advised by Fritz Kowalski, made a hovercraft which actually goes on land and water, radio-controlled, has a good turning radius. The premise being you can give teams the prototype and then they can modify the prototype throughout the semester and compete, things like that. So why am I saying that should be a finish and sustain thing? Well, we've got the prototypes lying around, so we need somebody to take this ball and run with it. So if anybody's interested in doing that, please reach out and let me know, and then we can have the first university-level radio-controlled hovercraft racing league. I think it'd be pretty exciting. But that's something engineers can do. Improve, the green one up there, okay? This, again, was one of the best teams I've worked with Capstone, and what they did was they worked with a company called Vibeco down in Rhode Island. And Vibeco makes plate compactors and rolling compactors for asphalt, things like that, and they do a hell of a lot of community stuff for Rhode Island. This team was charged with working with a VR18 reversible plate compactor, which had some manufacturing issues and the ergonomics of the handle were all rough. And what they did was they completely remanufactured the system, allowed them to use a much lighter and more easily manufacturable eccentric, and also made the handle a lot better. So this team did not create something, but they just dramatically improved something and made an impact as a result. So there's all kinds of different opportunities to go through these things. Listen, consider, convince, things like that. I'm not going to go too much into this, but whenever you guys learn about history and whenever you learn about technology, oftentimes we think about interchangeable parts or mass production or steel. And the idea is that, okay, this better technology came about, and then people just adopted it. Well, if that's true, how come people aren't just adopting wind power left and right? The answer is, throughout history, there's a ton of different examples of people bringing a new technology or new way of thinking to folks, and people even killing each other over not wanting to change. So a huge part of innovation, again, is not just the technical goodness of the idea, but how you actually get people to adopt that idea. So if you guys want to be even more powerful, give that some thought and think about how you're actually going to get people to maybe see things your way. So, second one, following on that with collaborating. You want to collaborate, okay? I've seen that. You want to collaborate, and everyone respects that. We talk about teamwork here, and I think you start learning it in your GE courses right away, okay? So this is what happens if you get Google image of collaborate, okay? You get the typical overblown sort of, chemistry professor taking his students skiing and things like that, and you know this guy's in a fight with this guy, and this guy's over here, and that's why they're sitting there, but yay, that's the, happy family photo. You get the wonderful NASA ones where I think a lot of times these people would actually rather be, kind of doing their work, but then you get stuff like this. I don't know if you've ever collaborated like this. I mean, that's kind of a nice bottle job there on this guy, and he's got an awesome tan, but then there's this, it's like, yeah, I really love this building. I mean, this collaboration, we just treat it as this happy thing. If you put well-minded, well-intentioned people together, they'll just do it. No, that's wrong, okay? Collaboration is probably one of the hardest things you can do properly, but it also has the biggest payoff. And I kind of feel, from what I've seen, again, this is from Capstone and other things, engineers typically don't explicitly address this enough. So I'm going to mention some things about this. Collaboration is hard, okay? Now you can do it, you can coexist, that's fine. I've seen a lot of teams just get through things without killing each other, but if you really want to collaborate and stretch and have good conflict, it's a little bit more difficult than that. Okay, here's another buzzword. It's actually 4 buzzwords, unless you're like one of those people who doesn't think and is a word, but it's a few buzzwords. Fail early and often. Who's heard this term? Good, okay. I kind of think this is overused, okay? I'm sorry, I'm cynical, I'm very, very old, but I do think this is overused. And the reason why is because sometimes people come to me in like different design things or Capstone or whatever, and it's like their first approach to a technical problem is, oh, we're just gonna fail early and often. It's like that's a prerequisite for doing something. You are not a true engineer unless you've taken 2 expensive things, put them together, thrown them off a desk, and then you kind of saw what happened with really no thought as to what the results might be. But damn it, you failed early and you failed often, so hey, that's great. This is kind of how I feel about it. If you use this term wrong, you're going to end up like, I mean, there's a lot of situations where you really don't want to do that. I do respect the term, but just maybe think about what it really, really means, maybe towards a purpose. Don't just sort of play with things. I think you can fail early and often in collaborations, and this is something that I've learned. Again, people don't address this explicitly enough in our field. Collaboration is not necessarily about making friends, okay? It's about working together. It's about challenging each other's assumptions, challenging each other's ideas, and creating a stronger team and a stronger product as a result. I bet a lot of folks, a lot of you are going to get involved in, say, alternative energy, something like that. And maybe 1 or 2 of you might have to go to North Dakota or West Virginia or something like that, or Kentucky, where a lot of people make their living off coal. You're going to go to some town hall, and you're going to be representing your solar company or whatnot, and there's going to be 5 people in that room saying, you're not going to take my job. I have a very real reason for not wanting to adopt your technology. What are you going to do then? Come back to Boston and say, wow, I met some morons, or something like that? Or are you going to try and work with people? Those situations are difficult, and they're going to come to you a lot quicker than you might think. So there's different ways that I work with, that I kind of teach students in this. This is something I do during my Capstone meetings. It's uncomfortable for a lot of people, but it's the idea of just don't interrupt. And that's a very, very sort of simple thing that you can do to make a meeting go smoother. Saying things like, you're misunderstanding me, as opposed to, saying that is bad, but maybe you can say, you're not making yourself clear. These are 2 bad things. But if you say, I don't understand, or I'm not making myself clear, it's just little things like that, okay? Different ways of working with each other. This is Todd Barber. He's the lead propulsion engineer on the Cassini probe, the one that just already took those wonderful, fantastic pictures of Saturn a couple of years back, and it just finally did its last dive into Saturn. And he told me that folks on his team were basically the whole time they were thinking, oh my God, I don't think this is going to work. I mean, that's apparently a thing at JPL. They don't think a lot of their stuff is going to work. But they say, if this thing doesn't work, at least it's not going to be because I didn't do my job. And that's a very healthy perspective to bring to these things. We try and bring that to Capstone. And then, there's this book, which, Harry Potter and stuff, I don't know if anybody likes it, but I mean, there's a decent quote out of that, which is, it's much harder to stand up to your friends. And this gets into another point, okay? I don't know how much we can learn from weightlifters, but I think we can learn this from weightlifters. I've noticed that when people collaborate and then they have conflict, they just sort of say, all right, fine. We had a fight, and we'll go back, the fight's over, whatever. But conflict, if you want to get stronger, is just like any type of exercise that you do. You can't just lift a bunch of weights and then go home and then lift a bunch of weights the next day and expect to be stronger. You have to lift, push your limits, but then you have to repair the damage and try not to overtrain. And this is, I mean, again, I'm just going to throw some open-minded ideas out there, but if you guys are going to be collaborating with each other and really trying to generate some good conflict, you have to respect that as part of the process as well. Not just, okay, let's have a fight and go. If you have a fight, you have an argument, go and fix it, and then you can be stronger later on. It's some kind of strange ideas, you know, but it's just stuff that I've noticed and that can be successful when people collaborate. Again, especially as you guys are going to start reaching across the aisle and really starting to try and push some innovative ideas. Okay, here's another one. You're independent, but you appreciate a starting point. You guys are really independent. You're really independent learners, and I've seen this in dealing with many, many of you. All you need is a starting point, okay? It's not just like, you know, you're okay being thrown an open-ended problem. That's great, and I've seen you guys really, really run with it. You don't need your handheld, but you definitely appreciate a starting point. And I'm going to give you some ideas on how you can do that. Okay, so I don't know if you guys are learning this either in, you're probably learning this in sort of materials thermo, maybe your thermo, and maybe in materials science. Does any of this make any sense to anyone in this room? Grown-ups can, okay. No, all right, great. Okay, this is called heterogeneous nucleation. I'm just going to skip right to this picture, okay? Or why bubbles form on the inside of a glass and they don't just naturally form inside the liquid. And the reason why is when you generate something new, a new phase in materials or something like that, you got a liquid, the liquid has gas in it, and that gas comes out of solution in the form of bubbles. It takes an energy cost to make the surface which is around that bubble. Okay? Same thing when something solidifies. If you have a liquid and then you freeze it, it wants to be at a lower energy state as a solid, but takes a little bit of energy to create that surface between the solid and the liquid. Surface energy. Surfaces are expensive. So if you were to just create some random sphere, then you would have to just spontaneously deal with all the surface energy associated with that. But if you create something on the surface of a solid, or the surface of a solid here, then when you create this liquid, you're getting rid of this solid surface, and you're creating this liquid surface. So it's less expensive. You're kind of trading one surface for another. And it's called heterogeneous nucleation. It's a neat idea, and it's why we see clouds. It's why things freeze off the walls, certain way they do. It's responsible for a lot of different things, but it's also a neat way to think about idea germination, okay? How many of you have an easier time editing somebody else's work, or your written work, than just generating something and writing it yourself? It's typically a lot easier to fix something, to mend something, to alter something, than it is to completely come up with your idea out of the blue. And that's this whole idea of heterogeneous nucleation. I wanted to throw some science in there, and I'll give you some ideas, okay? I'm working with a team right now, okay? I'm working with a professor named Emily Zimmerman in Bouvet College of Health Sciences, and we're trying to develop pacifiers that work well with children who have cleft palate, okay? The problem with cleft palate is when the kid is trying to suck on the pacifier and develop their sucking skills, they have this hole in the top of their palate, which is pretty much right there. So they can't generate the negative pressure required to actually suck. So before we can test these pacifiers that we make on children, we're making an actual test setup, a simulator of a baby's mouth who's actually, you know, sort of sucking on a pacifier, and we're attempting to simulate it. So if we make the tool and show that it works, then maybe we can test it on children. And then if it's safe for kids, we can test it on cats. So but what these kids are working on here is a box that's going to drop the jaw, or the virtual jaw of the kid, and supposedly generate the negative pressure associated with that. And basically their starting point for that is like, well, what do we do? Well, the first thing we do is we say, well, can we actually generate the pressure associated with that by increasing the volume? So the starting point for here is just the ideal gas law. Once they have that starting point and they figure that out, they can run with it, okay? We have another group, bioengineering group. They haven't really taken any heat transfer, but I tell you what, they are making a plethysmograph for mice, which basically allows you to measure lung volume in mice by measuring the pressure and the temperature of the air that's going in and out, that type of thing. And they've never taken sort of a heat transfer course to understand how this mouse is going to affect the environment around it by, you know, either radiation, convection, conduction, things like that. They sat down with Greg Kowalski. He gave them some basic equations. Boom. Okay? They didn't have an entire course on it. It would help, but they were able to start with just a half-hour conversation. And I've seen this in all of you. I've seen this in that given a starting point, you can really make things happen. Okay? I'm not going to talk too much about sort of the fundamentals. We're going to get back to this idea of an information age. Okay? Everyone is doing something here. So the quote, which is here, is whenever you're coming up with a challenge that you're working on or an invention, it's kind of more fun to say somewhere, sometimes, someone in the world is considered some of something that is somewhat similar to some of our challenge. There's a lot of people out there doing stuff, most of them on YouTube, and they are all doing inspiring things out there. There's a lot of ways that you can get inspiration from other fields to address your ideas. I'll give an example from my own history, and then I'll give a plug for this industry. I used to work in thermal spray. It's a global industry for surface modification. And basically what happens in thermal spray is you take powder of any material pretty much, and you drop it in a hopper, and you accelerate it at very high temperatures and very high velocities where these liquid droplets splat and rapidly cool and solidify on a surface. And if you have lots and lots of these little droplets, they form a dense coating like this. Okay? Now these people are working in the oil and pipeline gas industry. These people are making turbine blade coatings, yttria stabilized zirconia. And this one's really neat, because you figure this is basically a torch that's firing particles out at 200 meters a second. Some folks at Ford actually figured out how to turn that whole crazy nonsense sideways and rotate it around real, real fast. And now they're able to thermal spray the inside of engine bores, which is one of the reasons why engines can go to higher temperatures and they're more efficient and things like that. That's hard to do. Before I move on with this, I'm going to say that it really doesn't take much to go look at a thermal spray shop. It really doesn't take much to start one of these. So if any of you are surface modification minded, there are a lot of shops out there across the country that have contracts just finding ways to thermal spray new materials for new applications. And if any of you are interested in this type of stuff, there's a lot of opportunity to go out on your own really quickly for that. Nevertheless, these are splats. We look at them, we look at their morphology, which is their shape, and this morphology is affected by the process conditions and things like that. But where am I going with this? A couple of years ago, we looked at some splats and we pulled them off a substrate, and we saw they had a bunch of holes in them, okay? A bunch of bubbles in them, and we were wondering, well, where the hell did these bubbles come from? Nobody had really ever looked at these before, and nobody ever saw them before. So long story short, we came up with a hypothesis of, well, we think what happened was this liquid droplet was flying towards the surface, and when it hit the surface, there was a very high pressure, and that forced the gas into solution, just like a can of Coke or something. And then, when it impacted, it depressurized, because that pressure only lasted a nanosecond, and then you get bubbles fizzing out at the interface. Oh boy, we were real proud of ourselves. We were like, oh, that's a great hypothesis. Now, who gets to do the math to figure this out? We didn't want to. So we figured, well, let's go around the world and see if anybody else has done this. And luckily enough, we did that, okay? We found out that this is very, very similar to what happens in a volcano. In a volcano, you get magma, which is real high pressurized, and when it depressurizes as it comes out the volcanic cone, bubbles come out. And apparently volcanologists are very, very interested in that. So interested, in fact, that they made detailed quantitative physical laws to describe this. Detailed quantitative physical laws that we could then use. See, there's enough room to play for everyone. And we were very, very happy because we could use their equations to match our data very, very well and quantitatively predict the mechanism, and the hypothesis was proven. It was really, really cool. But the point of this is there's some people, again, in the world who are going around just looking at stuff. And there's some people in the world who want to look really deeply at one problem. And one day you might want to be one day you might want to be the other, but there's plenty of room for people to work together. A couple other ones, really, really quick. On this Capstone team, they needed to make an onboard dog treat dispenser for keep going behavior, particularly for service dogs, for emotional support dogs, for PTSD and stuff like that. So this collar actually is remote controlled and ejects treats out of it when the dog does a good job. There's a fantastic YouTube video of it with these guys. It's called Good Collar. But one of the things they really struggled with was, well, how do we make sure the treats don't fall out of this thing? It's actually a little bit of an engineering problem. And they were quite clever and creative, and they were able to think about how straws are held into, what are they called, like sweetheart cups or something like that from McDonald's, and they were able to take that analogy. An analogy is huge in engineering design, and if you think about it and you allow yourself to open your mind, you can go quite far with that. Again, this is a CubeSat visual inspection camera. This team was tasked with making a visual inspection camera to look at whether subcomponents of CubeSats were deployed visually. And after working with a bunch of different things, they came up with this idea, which was inspired by a military compass. Again, they got the idea and the mechanism and the shape and the visualization from something that already exists. And there's ways you can do that with quantitative laws, but sometimes it's great if you just kind of look around, okay? And then they invited us out to JPL, and we got to pretend to be mission control and things like that. We're not actually doing anything there. We're just kind of looking pretentious and stuff. So, last one. I've also been lucky enough to work with Parkinsons and essential tremor, and I see quite a few of them in the room that I've worked with on this. There's two things here. This is an interesting thing, and I just sort of chalk it up to degrees of freedom. And this is another thing which I'm gonna tell you after I get through this. We developed a patent to help people who are having trouble putting their zippers together by creating a little zipper guide that you can put on the end of your coat. It's actually really, really cool. Okay. These two, this is Yi Zhang and this is Fiona Ji. They basically realized that if you've got Parkinson's or essential tremor and your hand is shaking a little bit like that if you just basically lean on a tennis ball, the tennis ball has all the right friction properties and all the right insulative properties, that if you use a tennis ball and you lean on that when you're using a touch screen, boom, creates much, much, much more stable behavior. It's fantastic, okay? And they did this just by working with degrees of freedom. And what I mean by that is, anytime you're leaning on something, anytime you're leaning against something, either a table or a wall, stuff just gets easier, right? Like if you're leaning here, writing gets easier. If you're leaning here, you kind of, more casual. I would actually argue, just like with my thermal spray thing, if any of you were to think about a device that would help somebody lean on something, but something you could take with you, something that could lean on a table at restaurants or something in your car or whatever like that, you could probably come up with some real innovative stuff. So I'm just going to throw that out there right now. Can you create something portable folks can lean on in very specific situations? I bet you could brainstorm about that in lieu of listening to me. So you develop these starting points through practice, and this is where I'm going to throw something out. Okay, apparently Albert Einstein developed a lot of his stuff because he worked for the patent office, and apparently he was good at distilling ideas. I didn't research this. This might be, urban legend or whatever, but for now, we'll believe it, okay? Yeah. This is what I think, and this is going to sound like a thing on you, but it's not. This is an opportunity. I don't think engineering students practice enough, okay? I don't think you do. I mean, I think you do a lot of work. I think you're hard work and stuff like that, but there's some stigma that I've seen in engineering education about people just doing more problems than they're assigned, or just practicing, or doing a ton of homework problems out there, a ton of just practice problems. And part of that is the way that we want to recruit engineering. And part of that is due to sort of educational research. It says, well, there's lower levels of comprehension and there's higher levels of comprehension. This is called Bloom's taxonomy. And it says students, they have facts, they understand things, and then the holy grail is to be able to create. But we often bypass this idea of practicing. For some reason, anytime anybody wants to do 20 problems, oh, no, they're just a robot learning for the test. And I think that's patently unfair. We know stuff like active learning, and I think this is great for engagement in the classroom, but I tell you what, there's a fantastic opportunity for people to just do more problems on your own. Exams aren't supposed to be rough, okay? They're supposed to be kind of like a celebration. Every other field out there where anybody is doing anything worth doing, they are practicing, okay? They're not just looking at concepts, they're not doing this, they are literally going through rote, okay? Anything from musician to sports to martial arts, art, even writing, Writers, what do? They write every day, they keep themselves sharp. So again, this is a message, there's an opportunity for you guys to practice a lot more, and I can almost guarantee that if you do practice this stuff more, the fundamentals and type stuff, you'll be sharper, and sometimes the exams will be a little bit less pressure. And I'd be happy to talk to anyone more about that. Okay, here's opening something up here, okay? When I was in grad school at MIT, these people put up these posters, John Robert Powers School of Modeling, all over MIT. Okay, fine, I'll go try out, that kind of thing. So I went, and they told me, oh, you're fantastic, great, you're going to be the next, this guy. They just wanted my $700. I so got taken. Anyway, so I went to this stupid modeling school on Sunday morning. It was like, I didn't learn anything. I went to all the rejects and stuff like that. But they had some coach who went with us. And I learned two things from John Robert Powers. One was I talk too much with my eyebrows. And two is even actors practice their fundamentals. Actors, they go up on screen and they emote and things like that. But the ones who are really successful, they practice. They practice their fundamentals. Again, I don't think we practice our fundamentals nearly enough. Okay? And if you do, I can almost guarantee you're going to do way better, and it will set a lot of people's minds at rest. And I think it's the opening of a cool discussion. Okay, are you an expert? This is another thing I like to think about sometimes, okay? When I meet new students and they're going through classes and stuff like that, I ask them, are you an expert in anything? And an expert it's not 10,000 hours, but an expert is something where if you were to have a conversation with anybody in the world about this particular topic, you'd be able to hold your own, even if they argued with you, even if they challenged you. It can be anything. It can be about machining, it can be about baseball, it can be about transformers, driving, whatever, something you're enthusiastic about. Are you an expert? And by and large, students generally come up with something where they feel that way. Yeah, bring them on. I could talk to anyone about that. And the challenge that I ask them is, can you feel that way about your courses? Can you feel that way about the discipline you've now chosen? Or if not, what is it about the discipline that you've chosen that makes you think that you can't be an expert? Why not? I mean, you've done it a bunch of times before. So it's kind of a mindset I'd like for people to think about a little bit, okay? All right, this is a side note. Some of you are going to work with wearable technologies, and some of you are going to have friends who work on wearable technologies, and some of you are going to just, deal with this type of stuff. You're going to have a friend one day who says, hey, I'm working on wearable technologies. Can I store my mannequin at your house? And you'll be like, yeah, okay, fine, because maybe you want to be friends with them. One day, this is great, I'm a big spirit and things like that. You're going to forget there's a mannequin in your house. It's either going to be when you come home late at night and you're late, whatever, or when you wake up in the morning. So just don't, because then you're going to spill coffee or something like that. So just think twice before you let your friends keep the mannequins in your house. You often consider all viewpoints and perspectives, sometimes to a fault. And I've heard this. I've heard students come back, and this is why I get a lot of emails as well, too. I don't know if you've heard any of these sort of paraphrased, okay? I've seen these. I've heard students come back from co-op with something like this, okay? I've heard students talk to me about they've talked to their idea about somebody, an invention, and somebody told them this. Somebody told them this. And this is something that we see in Capstone quite a bit. You get students who've been working for 4 months on a project, and then somebody just, I wasn't listening or whatever, but this happens, and the students are like, well, what do we do now? This professor is just challenging us. Are we supposed to tell them they're wrong? Well, maybe. But I want to tell you again, you are not alone, okay? This stuff happens all the time, but are you really going to let somebody who just had a bad day, dictate the next 2 years of your life? Because that's effectively what you're doing. If you're responding to this stuff, you're just like the person who's at a red light, and somebody beeps at him and you go because somebody beeps at you, right? I mean, how nuts is that? That's this stuff. You guys are so respectful of the world around you. That's why I said to a fault in some cases. So I'm not telling you to go and just flip everybody off. No, I'm saying just think about this and think about, really, am I going to let this kind of shatter my center? Okay? I do this all the time, okay? I was called stupid for 2 years when I worked at the hospital. I went from nanomechanics to working on lungs. I didn't know anything. And the people at the hospital would continually tell me and challenge my assumptions and say, I really didn't know what I was talking about. And that was fine, because I sort of learned something about it. And if you put yourself in uncomfortable positions, you can become, quite powerful in that. Learn to enjoy and trust your own company, okay? A lot of people are always looking for mentorship or somebody to tell them they did a good job or that type of thing, or some type of external motivation. But if you can really learn to find your center, this can be something good. All right, I got to zoom. Okay. This is another conversation we have sometimes, okay? You sometimes wonder what you should do, okay? Somebody say, he literally comes to my office and say, what should I do? What do you mean, what should you do? No, what should I do? I'm like, well, for the next 40 years? I'm like, yes, wow. That's a big question to ask me, but it's okay. I'm up for it, I guess. I usually give some type of answer. Anyway, you sometimes wonder what you should do. And I like that, because you outwardly sort of wonder, am I going too fast? Am I going not fast enough? Am I going slowly? What am I doing in this world with all this great stuff I mentioned? This was a talk that we gave. This is Andrew Waite, and this is Danny Walsh. And this shows you how far Capstone can go sometimes. This was a farm arm, which was a prosthetic tool for farmers. And we got invited to participate in Dewey Design Week in 2006, which was really, really great. And this is me giving a talk, and this is like an arty kind of talk, so nobody stands up, they all sit down, and you can tell that guy's riveted. But I'm giving a talk here on what design should do. That was the talk. So they gave me the microphone, and my take on it there was kind of this, okay? Nobody owns design, and nobody owns innovation. And that's something I want you to think about as well, too. As engineers, it's not only our exclusive realm to make stuff and to bring stuff to market, but it's also not our responsibility either. Again, if we're not just pulling stuff out of a vacuum, but we're able to work with folks and make their ideas better, there's a lot of opportunities there. So hopefully I can give you kind of something to think about in that regard. This is one thing I like to think about. Sometimes I like to judge my actions on who I want to listen to me. I will have, not much anymore, but I'll often have a different conversation if I want to have a conversation with experts in my field versus general society, people on the T, or people I work with, or kids. I mean you guys as peers. I mean kids as kids, like literal sort of 6-year-olds and stuff like that. Define your actions by who you want your audience to be. You don't have to satisfy everyone. I think what I've shown you here is that there's a bunch of different paths to go through this. So maybe this is a way to go. Think about who you want to listen to you. Hold on to your inspirations, okay? I'm kind of opening myself here. This is the type of stuff that inspires me. Anybody who just gets their stuff done. I go nuts for that kind of thing. This is Myrtle, cat with no eyes. The folks that, the folks that created cathedrals and things like that, these people would start building cathedrals knowing that the construction would be finished after they died, but they still did it. What kind of devotion does it take to do that? Colin McRae, If in Doubt, Flat Out, Avatar, and pretty much all my students. So, find things to inspire you and use them. Keep asking why, okay? Because there's nothing more boring than somebody telling you about an idea, and you say, well, why'd you do that? And say, well, I just want to see what happened. The conversation ends right away. People want to know why you did something. In Capstone, it doesn't matter how cool the idea is, we care about how you guys made your decisions. So, there's always someone watching you. You guys are young, you're really young, but I guarantee there are people now in high school or around their peers taking their cues from how you guys make your decisions. It's amazing how quickly you can affect people. So kind of remember that as well too. So I think that's all I got for now. As you know, I'm happy to babble on about this, whatever, but we're out of time. So thank you very much for listening, and if you got any questions, come see me. Thank you.